Okay, good morning, file size 1 and file size 3. So today is Wednesday, is our last lesson of this week, okay? Nice to meet everyone here again. So I a little bit late just now, okay? So far so good lah. No student throw any fire cricket, so it's okay lah, huh? So the last 3 classes having the last paper today, Pendidikan Moral and Pendidikan Islam, okay? Last paper, because they only take one elective paper only. So after this, we have only like chemistry, bio, MX, all this paper, economy, perdagangan, principal account, they are not involved. So they can celebrate already. So hopefully nothing happen. We have enough teacher in the canteen to check. Okay. Right. First thing I want to tell you all is regarding this folder, your homework which you have passed up, right? Okay, the one you can come and collect. I already put the pictures there now, you can see, right? So they are already put inside the boxes there. You can come and collect your box at the same time. Not collect your box, collect your folder. And at the same time, you can collect the module as well. Okay, so the number of modules is only one set for you all. So please only take one set, okay? And sign your name. Now go and find the name list, sign your name. For example, like Form 5, so you can see there are 2 boxes carry the name Form 5. The 2 boxes are same one, so you just take one set from any of the box. Okay, one set only, the module. So take one set and then sign your name. The module is for you to do it as your offline assignment. It's offline assignment, or this one is prepared by Japatan one, So all the students have to answer the question, okay? As your offline homework lah. And the module need to be passed up, okay, class? Okay, some of the question actually repeated one. The questions are same as the module, same as the paper I discussed with you from chapter 1, chapter 2. Okay, almost the same one. So some of the question you can just copy the answer from your module. I don't know why they give the same paper, because the paper also they ask the school teacher to send to them and then compile to become like that. Okay, so remember that. Go and collect. You come to school to take back your folder, and at the same time go and collect the module. And also one more, so you need to pass out one set of your chapter 2 paper, okay, which is I think is liquid pressure. One set only, you pass out one set only. So remember, let's chapter 2. Now we are in 2.2, 2.3, right? Okay, we started with liquid pressure. After that, gas pressure, and now atmospheric pressure, correct not? So be it clear, you only pass up this liquid pressure. So listen carefully. Pass up only 2.1, okay, the liquid pressure paper. Don't need put in the folder, you just staple your paper nicely, write your name, okay, and your class, and put it in the small box beside the big box. You see, you see the picture, there's a small box, isn't it? Put it under there nicely, and please place a stone on top of the paper to prevent the paper from flying out, okay? There are stone there, so you take out the stone, you put your folder, put your paper inside the small box, and then step up with the stone on top. Okay, understand? Marvin, do you understand what I say? Marvin? Understand or not? Tan Shirley, do you understand? Tan Shirley?
Yes, sir.
Understand what I say now? McNish, do you understand?
Yes, sir.
Okay. And also another list class. The one list I put 1, 1, 1, 1, 1 mean you already pass up. And then you put beside the one, I put the red color 0. That means your works is incomplete. So you have incomplete words. Okay, please go and find which part incomplete. I put a remark there, complete it, and then you resubmit your folder again. Understand? So remember now, I already have all the record now. So please remember, the incomplete one, especially you have to take your folder back and check which part you are not finished, right? Now you better finish it and then you pass up your folder back to the box again. Okay, understand? Emily, understand what I say or not? Can hear or not, Emily?
Understand.
Emily okay lah, her homework okay one, no problem one. Okay, only a few lah. You can see in the list who the works not finished one, incomplete, and then those who never pass up one, that is the worst. Okay, 5 size one got 2, never pass up. Esther, are you here? Esther 1, please pass up your pass up as fast as possible. Okay, Esther. Lim Yen Ming here or not? Lim Yen Ming here or not? Ping Hao, can you check Lim Yen Ming got come in or not?
I think yes, sir.
He's here lah. Lim Yen Ming here lah. Got I didn't see her. Lim Yen Ming. Kim Yen Ming, are you here? Lim Yen Ming? Lim Yen Ming, pass up, please pass up your works, okay? Understand or not? Pass up your work, okay? Okay. So that's all lah. Okay, now I start lesson now. Okay. Okay, I share the paper with you. I hope you can see that. So we continue with our atmospheric pressure. Okay, last week we have discussed the uses of atmospheric pressure for a few examples. Correct? Not drinking straw. We have done. Have we discussed this one? McNish, have we discussed the drinking straw? Got or not? Got discussed this or not?
Yeah.
Got. Okay, now McNish, hey, turn off your mic. McNish, can you tell me how does drinking straw apply atmospheric pressure? Can roughly tell me lah. Tell your story here, McNish.
When you suck from the straw, the air pressure in the straw reduces. So the atmospheric pressure pushes the water into the straw.
Yes, very good, McNish. You show that you already understand. Well done, McNish. Okay, very good. Okay, another example, I think rubber sucker also, I think we have discussed, correct not? Ping Hao, have we discussed the rubber sucker, how this thing works?
Yes.
Okay, Ping Hao, now your turn to explain. How this rubber sucker using the atmospheric pressure to carry out the function. Okay, Ping Hao, please explain.
When the rubber sucker is pressed, the air is removed.
Yes, the air inside here is removed. Then what happened?
This causes the area inside the air sucker to be low pressure.
Yeah, very good. So inside here, pressure become low. What happened then?
Atmospheric pressure press the rubber sucker on the smooth surface.
Yes, very good. Mean higher atmospheric pressure outside will keep pressing this rubber sucker to stick on the wall. Okay, thank you, Ping Hao. Very good. Okay, next one is shrink. Shrink, have we discussed or not? Ping Hao, have we discussed this one?
Not yet.
Not yet. Okay, now look at this one. Shrink. Okay, shrink is a one normally a doctor used to inject, to carry out injection. Okay, how this thing work? This one also need atmospheric pressure. If no atmospheric pressure, this thing cannot function one. Okay, how to use atmospheric pressure? First thing, okay, the step is like this, to use a string, right? You need to push the piston until the end. Before you start to use, you have to push one now. Push the piston until the end here to remove all the air. You push it down until the end before you put inside the liquid lah. Before you put it inside. So you have to push the piston until the end to remove all the air inside. Remove everything inside, no air inside. Then only you put it inside the liquid or the medicine. After you push the piston down already, remove all the air already, then only you submerge it inside the liquid or inside the medicine. After that, you slowly pull the piston up now. You pull the piston up. So what happens is, when you pull the piston up, right, you have empty space here. Because when you pull the piston up, so you have empty space. So the empty space will become low pressure because no air. So it's low pressure. So the moment you pull the piston up, so you create this low pressure region here, empty space. So it's very low pressure. So automatically, when you see low pressure inside, atmospheric pressure, which is higher, will start to push the water from going in. That's all. It will push the liquid go in because atmospheric pressure is higher. So you see now, this atmospheric pressure will only start to act when inside is low pressure. Inside, by pulling the piston up, so inside become low pressure. So the moment inside low pressure, outside pressure become high. So it will push the liquid, push the medicine to go in. That's all. So this is the importance of atmospheric pressure, you know. So when we create a low pressure region inside, the atmospheric pressure will start to act. So you push the water to go in, push the medicine to go in. Okay, Okay, now this one, pulling up the piston reduces the atmospheric pressure inside the cylinder. This is very important. Okay, when you pull out the piston. Okay, and next, one moment. Next is the pressure on the liquid surface. The atmospheric pressure pushes the liquid up into the string. Okay, that's all. So this is how a string works. Okay, now you have learned three already. Drinking straw. One drinking straw. The second one is rubber sucker. The third one is string. Okay, now the fourth one is vacuum cleaner. Okay, surprisingly, most of us, we don't know, you know. Actually, the vacuum cleaner in our house can only function when you have atmospheric pressure. If no atmospheric pressure, this thing may not work one, you know. When you on it, you can only hear the fan turning, but the dust, the dirt will not go in, okay? We need the atmospheric pressure. Okay, how this thing works, listen carefully, class. Okay, So the moment you turn on the vacuum cleaner, so the fan is turning. The fan function is to suck the air out. This is the dust bag, right? The bag. So when you on the fan, you on the machine, so the fan will suck all the air going out, suck the air go out to make here become partially vacuum. Not total vacuum, it's partially vacuum. When the fan turning, suck the air out, right? So here become partially vacuum. Partially vacuum means the low pressure is very, very low pressure. Now, what happened is, inside low pressure, so outside the holes here, okay, here atmospheric pressure which is higher. So it will push the dust, the dirt, whatever thing, it will push it, go inside the holes and to be accumulated here. This is how vacuum cleaner work. Understand? So the fan is very important. You on the fan, you can hear the noise are very noisy those days lah. But now the latest technology are very quiet. Okay, the fan suck out the air inside the dust bag to make this part become low pressure. Less gas low pressure lah. So inside low pressure, immediately atmospheric pressure is higher. It will push whatever go in go inside here. That's all how this thing works. Okay, it's proven, you know, without atmospheric pressure, this thing cannot work one. Okay, a vacuum cleaner produces only a partial vacuum. A partial vacuum only is enough already. Partial vacuum is also mean low pressure. The fan inside the cylinder blow the air out. Okay, blow the air out. Not blow, actually suck the air out. Okay, with less air inside, the air pressure drops. Air pressure here drops. The atmospheric pressure outside then pushes up the to the cleaner hose, carry the dust and the dirt. Okay, so vacuum cleaner, okay. So this is the fourth one, isn't it? So remember, no, later on I may ask you to explain how this thing. Not I want to ask you, even in the SPM, I tell you, they can give you a diagram, like for example, vacuum cleaner. So they just ask you to explain the working principle of the vacuum cleaner, then carry 4 to 5 marks. So it's very important in physics. You must know how an apparatus or instruments work. They always ask working principle, how this thing work. They ask you to describe. Using, of course, need to put in physics concept lah, how this thing work. Okay. Understand? Leong Jian Sing, understand lah?
Yes, sir.
Okay. Actually, 5 size 3 not bad, you know. I mark their paper, many of them, their works, very good one. So I give very good grade to them, good, very good. A few of them got very good, a few good, but also got some never finished, incomplete work. Then also pass up. And the worst is there are 6 to 7 of them never pass up. These few boys never pass up one, you are in big trouble. No, I know you are not here. You don't know what I'm scolding you now. So those who are here, please convey my message to them. Okay? For those who are not never pass up one. Okay? When they come back to school, they will be big trouble for them already. Okay? You know why? I already explained, right? This is one part of the evaluation. Given marks to you. You don't pass up, mean you don't get marks. People get 10 marks, you get 0. First time. Second time, never pass up, you get 0 again. People have got 20 marks. So it's very important to pass up lah. Okay. Before this, I never emphasize so much collecting and marking the paper, you know, because now the Jabatan give the new instruction, the regulation say that student need to pass up and then we need to record the marks. Just to spare, if anything happen again, the school close again, no exam, so you don't have mark. So we will take this one as your mark. That time, then your father, mother don't come to school, say, why you give 0 marks to my son? My son study very hard at home, very hard working. My son is very smart. Why you give him 0 mark? Then I take out the paper, like your son never pass up. Never pass up a single job, single homework, never pass up, 0 lah. Okay? Okay, all right, next, lift pump. Okay, lift pump is a machine used to pump the water from a well, pump the water up. Okay, use this one, not using electric one, using hand to pump the water go up. Okay, this one also using concept atmospheric pressure. No atmospheric pressure You see the message all sort of message PK pentapuran from Jabatan, you know, the whole morning the message coming asking this one, asking that one. So sometimes we get fed up. We are under pressure, you know. Class student, you ought to know, you know. Teaching online, they ask more things. They cannot come to school, so they ask this one, other. How many students never attend your class? Every day we have to send report to them. Okay, and now even SPM, every day we have to send report. How many students never turns up for the SPM? What is the reason? Did the school contact the student? They never come to the school, call them to invite them to come to sit for the exam like that until that extent. Okay, let me tell you one thing now. This morning, moral paper, Agama paper, 5 size 1. There was a girl, no, 5 size 1, never come to sit for the model paper because she wrongly the timetable. She thought model was in the afternoon, so never turns up. Never turns up, 5 size 1 girls, also never refer to the timetable last night before she sleep. Okay, the worst thing is what, the Guru Petugas went up to ask the Ketua Pengawas. Ketua Pengawas said, semua hadir, all present. Semua hadir, never check. Then luckily, this teacher, very hardworking, Datin Tan Xiaoping. She's teaching moral. She went to check the name list in the canteen. This girl, how come the girl never signed the attendance? Then she went up to check. Then she noticed the place empty. Then only we call the parent. Then the mother got a shock. The mother immediately screamed on the daughter, asked the daughter to wake up. Sleeping, the moral paper started already. The girl was sleeping at home. I don't want to tell the name now. 5 size 1. Now, this thing can happen one, Actually, if Datin Tan, I tell you, if she never took the effort to when she trusts the Ketua Pengawas 100%, she never went up to check. This girl may miss the moral paper. Then only afternoon she comes. The afternoon she comes, she's gone already. You see? Student, you all must learn the responsibility, as the candidate side. Tomorrow, what paper? Before you sleep tonight, you must check check the timetable. You're given the timetable. Everybody given the timetable. But yet can happen. Good students are more. 5A, 5 size 1 girl. And then when she reached the school, 35 minutes late already, she cried. Crying. Worried the Ketua Pengawas disallow her to go in. You know why? No. After 30 minutes, they can stop you from going in one. So we have to talk to the Ketua Pengawas, talk to them, okay, appeal to him, and then only he allowed her to go in. Okay? And then I have to sign the paper. Sign so that allow her to go in after 30 minutes, Actually cannot one, The regulation is after 30 minutes, you cannot go in already. So we have to help her what to do. Okay. Sorry, I talked too much already. Ping, how you understand what I say?
Yes, understand.
So next time, next year, this year is your turn, So you want to check your timetable carefully. If end classes they never come, we know, we understand when they do want to come, they come and don't come also same month they will fail. But also we call them, okay? The good thing is one, like this morning, 5 size 4, 5A5, 5A4, nobody absent. They came. Okay? Only the 5 size 1 got 1 girl, surprisingly. Okay, come. How this lift pump work? Okay, this lift pump, the important components are the valve. You see here, this is valve A, valve B. There are 2 valves here. The valve means is something like a window, can open and can close one. So this valve A, another valve is they can open and close, so allow to stop the water going in, allow the water to go in, they can open and close lah. Okay. The thing start work like this. Okay, I follow here so that you can follow also. This is a plunger. Okay, plunger means you can move the plunger so this thing can go down, go up, go down, go up. The whole thing this is a piston. Understand? So when you move the plunger up and down, this thing will you also follow one, go down, go up, go down, go up to pump the water up. Okay. So first step is like this. Valve, when the plunger is lifted, you lift the thing up. Okay, follow this arrow. You lift the thing up. This part go up, so this part will push the piston down. Correct not? Understand? When you lift the plunger up, so this one go down. The piston, the whole thing will go down. What happened was like this. When this thing go down, this thing sure open one. Valve A closes. Sorry, when you push down. This thing go up, this one come down. Okay. Valve A closes and valve B open. This one will close because you apply pressure. You press on it. Once you press on it now, so it will close. Close this thing. Okay. The moment this close, actually now close means to prevent this water from coming down, okay? And because of the, when this one closes, okay, then here this one will open. Why open? Because the atmospheric pressure will push the water to open the valve. Then the water will go inside the space here. Okay. So remember that the moment you lift the plunger, this thing come down, presses on the valve, so this valve closes. When the valve here closes, this one will open. Why open? Because atmospheric pressure press the water, push the valve to open. And then a lot of water fill up here already. Okay. First step, man. Atmospheric pressure acting on the surface of the water cause the water to flow past the valve P, okay, go inside here, okay? This is first step, okay? After that, you push the plunger down now, okay? When the plunger is pushed down, so you push the plunger down, here you push down, so this part will go up, correct not? This one will go up. When this thing go up means A will open immediately because you lift up, you don't apply the pressure on the valve already, so this one will open. This one open, the water, because got weight, so the water will press on this valve so that the valve B closes. Plunger push down, this one push down, this one go up, so this one open, this one close. Valve B closes and valve A open. This one will close. Actually, close is good to prevent this water from going back. This one close lah, lock the water here. This one open, okay? When this one open, automatically the water will go up here, okay? Water flow above the plunger. Then the water here will go, because once the valve open, water will flow up, fill up here, okay? Yeah. Okay, hold on now. When the plunger is pushed out, you push out this one go up, so A open, B closes, okay? Water flow, B closes, A open, water flow above the plunger, water go up, okay, go up here, right? Water go up, so now the water is transferring from here to here already, okay? Then it can go out, okay? Go out from the mouth, okay? The atmospheric pressure acting on the surface of the water forces the water past the valve. Okay, when you repeat the process lah. Okay. Just now I already explained one cycle. Okay, when this plunger lift up, this thing go down, this valve closes. When the valve A close, valve B will open. The atmospheric pressure push the water, fill up here. Fill up the space here, okay? Okay. After that, you push the plunger down to lift up here, lift this thing up. When you lift up here, the valve A open. And valve B cannot open, valve B will close because the weight of the water will press the valve to close. Okay, the moment valve A open, the water flow inside here. Okay, water flow here. Okay, so that complete one cycle. After that, you repeat again the whole thing. Okay, when the plunger P is neck lifted, valve A closes, B open. Okay, repeat again now. Atmospheric pressure acting on the surface of water forces water past through P into the cylinder. Simultaneously, the water above the plunger lifted and flow out through the mouth. Okay, you have to keep lift up, push down, lift up, push down a few times now. Okay, a few times, then you can pump the water go up. Okay, okay. Okay, so can I understand? So once again, you can see here, like atmospheric pressure is helping in pushing the water go inside, forcing the water to go inside the pump. Okay, so they are all together 5, right? First one is drinking straw, second one is rubber sucker, third is a string, fourth is the vacuum cleaner, and the last one is leaf pump. Okay, so make sure you get it, understand everything, okay? Okay lah. So now I want you to answer the objective question. Okay. 什么事？什么事？Who on the class? 你是那个 EMK 啊？你拿600块的是什么的？
我不懂是哪两个，我没有动那钱，我也没有问，因为讲我有一个布子内，
啊哈，
因为我没有读完。
可以，那个要拿，你是 Form 5的是吧？你要去 office 那边啊，你找关找一下先，你跟关少威讲，关少威有在，你讲那个新那个 GPK ham 嘛，
跟那个语言
啊，以前我那个房间那个老师，你讲你要拿，他会带你去 office 拿的，OK，OK，好，OK 啊，class，OK，question number 1。Gas pressure exists because the gas molecule. Okay, why gas pressure exists is because of what? What answer? You share the answer here, can or not? Type your answer here. Esther 1, can you give the answer or not? Esther 1, gas pressure exists because of what? Because of gas molecule. Why does gas pressure, Esther? Esther, are you here or not? Esther not here. Okay, Leong Jian Xin, please help to answer. Leong, gas pressure exists because of what reason?
D.
D, yes, correct. Collide with the wall of the container. Okay. Yeah, Esther answer already. Esther is too late. It's okay, Esther. Okay, Esther, don't go away first. Can you answer question number 2? Some gas trapped in a cylinder is compressed at a constant temperature. When you compress the gas, which of the following does not increase? Esther, you read the question. The gas are trapped inside a cylinder and then you compress at a constant temperature. So which one does not change? Esther, do you know the answer? Try. Which one will not increase? The mass, the density, pressure, which one, Esther? Okay, let's see your answer. Yes, very good. Mass, correct, Esther. Esther, actually, you are a very smart one, you know. But you just don't like to follow instruction. I know you are the types of girl like that, Esther? Yeah, okay, nothing, no problem. Don't worry, Esther. Okay. So the answer is mass lah. Mass will never change one, you know, right? Mass will never change in whatever situation. Okay. Okay, number 3. The figure shows a cylinder containing gas. Here got gas. The piston is held fixed. The piston never moves. But the cylinder is heated. You heat it up. Use fire to heat up the gas. So why does the pressure of the gas increase when you heat it up? Why when you heat up the gas, why the pressure here become higher? Which answer is correct? When you heat up the gas, why the pressure become higher? Okay, let's call another student to answer. Joey Lim. Joey Lim, are you there?
Yes.
Joey, can you answer? Why you heat up the gas? Why the pressure become higher? Why?
The molecule move faster and hit the wall of
Yes. Correct. Thank you. The molecule move faster and hit the wall more often. Okay. Hot already, the gas hot, it will move faster. Okay. It will move faster. Then it will collide, will hit the wall more often. So the pressure become higher. Okay. All right. Number 4. The answer came out already. To see that. When the temperature of the gas rises at constant volume, the molecule move at greater average speed. Now, remember that, I think in chemistry, so you all learn, right? When the gas become hot, the molecule will move faster because the molecule gains more energy, so it will move faster. That's all. Okay, number 5. When a piston is pulled upward, which of the following is true? Piston pull upward mean like this. You see the diagram. Okay. So this is a piston, you pull the piston up. So what happened, which one is true when you pull the piston up? So there's gas inside. So which one is answer is correct? When the piston is pulled upward, so which of the following is true? 木之香, come out please, Mu.
Yeah.
Mu answer. When you pull the piston up, so which answer is true?
B.
B, yes, correct. The distance between the molecule increases because when you pull it up, right, the space here become bigger. Bigger space means the gas will move further apart from each other. Lah. So the distance between the molecule increases, okay? All right, number 6, the answer there already. Bowden gauge, manometer. So remember, to measure gas pressure, you only learn 2. One is manometer and one is Bowden gauge to measure the gas pressure. Bowden gauge and manometer. Okay? Now I have one question I want to ask. Who? Nicholas Ong. Nicholas, can you come out? Nicholas?
Yes.
Nicholas. Okay, to measure gas pressure, you see the answer, we use Bowden gauge and manometer, right? Okay, what about to measure atmospheric pressure, we use what?
The 14 barometer
14 barometer. Okay, one.
and a right barometer.
Okay, very good, Nicholas. Nicholas, he really follow the lesson one, he knows one. Okay, thank you, Nicholas. Okay, to measure atmospheric pressure pula, so we use barometer and aneroid barometer. So the name is barometer, remember that, huh? Okay, number 7. Number 7. What answer it? The figure show manometer connected to gas supply. So the gas push in here. So this one go down, this one go up. Now the question asks, if the atmospheric pressure is 76 cm mercury, determine the pressure of the gas. So the pressure of gas is here. So what is the pressure? What is the value of gas pressure here? So what answer? Very simple calculation. The gas push here, so the gas pressure is here. They ask you to count what is the values of atmospheric pressure. So what answer? Amanda Lee. Amanda?
Yes, teacher.
What is
E.
the gas pressure? Yes?
E.
How you get the answer, Amanda?
76 plus 30.
Why you plus, Amanda? Can you explain or not? Why you need to add up?
Because
Why you
just
need to?
because the gas pressure plus the 30 cm of the height.
Yes. You find two same level points. So you mean gas pressure equal to the pressure at this point. So the pressure at this point means atmospheric plus the 30 cm. So you add up. So over here 76 cm atmospheric pressure plus another 30 cm. So you see same, you choose the 2 point same level. So you find the gas pressure, mean you find the pressure here. So it's atmospheric 76 plus another 30 cm. So it's 106. Okay, thank you, Amanda. Okay, next. Question 8. Figure show the U-tube filled with liquid L, X and Y, different one. If the density of Y, this one density is 0.9, what is the density of X? How to calculate? This density 0.9. What about the density of X? What formula? What formula? Like? Sid Eiling, are you here? Sid Eiling,
Yes.
Wow, Sid Eiling, I really respect you. Your handwriting are perfect like a typewriter. When I mark your paper,
You do.
Sid Eiling. Your handwriting is like a typewriter, exactly same like typewriter one. I thought you type it, and I see your handwriting. Very, very nice. What formula, Sirailing?
A1H1 equals to B2H2.
Ah, yes, very good. So what answer? What answer, Sirailing? No, use this formula lah.
A.
The answer A, yes, correct. Row 1 H1 equal row 2 H2. Density 1 height 1 equal density 2 height 2. Okay, you are asked to find this density. So row 1 now. So height 1 here is 12 cm. So you put 12 cm. Then density of this liquid is 0.9. So the height is 0.4. So you get 0.3 lah. Okay, So remember this one important formula, This formula is very, very important one. Row 1 H1 equal row 2 H2. Okay. Okay, number 9. Figure show a mercury barometer. This mercury barometer. Okay. So the height here is H. Now the question. What happened to the height if the gas tube tilted? Tilted means you put it slanting like that lah. If you put it upright, it's H. You tilt it like that. So what is the height? What happened to the height of H if the glass tube is tilted? What happened? Nicole Chua.
C remain
C,
unchanged.
yes, never change that, remain unchanged. If it remain unchanged, how you place this tube and the height of the mercury remains the same. Never change that. Okay, number 10. Height of mercury in barometer will decrease when you can make this height decrease in the barometer. So which answer is correct? Height of mercury will decrease, or this one will decrease. So which one? Which answer is correct? Patricia? Patricia, can you hear me? Patricia, can hear or not? Or she cannot? Okay, Patricia, which one is the answer? The height mercury will decrease if, how to make the height of mercury decrease? You want to make this one shorter, mean that surrounding pressure must be dropped. So how to make this height decrease? What answer? Patricia, you know or not? Ong Jia Sin, any idea? Ong Jia Sin? You can hear the motorbike sound already. The student horn already. Inside school, they are very quiet. Outside school, we cannot do anything. They horn their car. Celebrate 5A3, 5A4, 5A5. Last paper just finished. The answer C. Yes, correct. The answer C. Atmospheric pressure decreases. When the atmospheric pressure decreases, so this one will become shorter. Because outside pressure low, so this one will decrease. Okay, Ignore them. They want to celebrate, they celebrate. Okay, number 12. Normally, mercury used in the barometer, the reason is what? In the barometer, why we choose mercury? I think last lesson I told you already, this one barometer, here, this thing. Why we choose mercury? Why we don't use oil? Why we don't use water and so on? Barometer, why must choose mercury? Why? What is the answer for number 12? Tan Yong Kiat. Tan Yong Kiat, can hear me or not? Tan Yong Kiat, are you here? What answer, Tan Yong Kiat? Yeah, tell me the answer, Tan Yong Kiat. Why we choose mercury? Why choose mercury in the barometer? Okay, let's see what answer Yong Kiat gives. He said D. Most people give this answer, I know. Okay, Now mine, okay, actually the answer is B. Okay, come on, you all listen, everyone listen. Not only Yongkian, I think most of you will also got you wrong, this question. Normally, mercury used in the barometer is because it has higher density. Mercury high density means the apparatus will not be so long. Mercury is heavy, heavy means the most here normally atmospheric pressure only 76 cm, so it won't be so long because mercury is density higher, so very heavy. So the most this thing can only go up 76 cm. So this apparatus will not be so bulky, so big, unless like you change water. You see, when you change water, this thing will become how long? If water this one become how long? Zhong Jiayin, if water, this one will become how long?
10 meter.
10 meter 10 meter is very, very high, so the apparatus become very bulky, not convenient. So that's the reason we choose mercury, because mercury heavy can make the size of the apparatus become smaller, more convenient. Okay, that's the answer. Okay, the other answer come, let me explain to you. Some of you want to argue one, I know, expand uniformly, memang mercury characteristic expand uniformly, high boiling point, and also does not stick to the glass tube. Okay, now let me tell you, the three things I think, this one is for choosing for thermometer. For thermometer, we choose mercury is because of this reason: expand uniformly, high boiling point, and also does not stick to the glass tube. Remember, no, these three answers are meant for thermometer, not for barometer. Barometer doesn't require the mercury to expand one, no need one. High boiling point also no need. Only thermometer need. Does not stick to the glass tube. This is not big issue So remember, these three ticks are meant for thermometer. You chose mercury, the reason. And for barometer, it must be high density. So the thing won't be so big. Okay, Okay, number 13. I hope you understand now. Okay, 13, what formula to use? Density of mercury given. Atmospheric pressure is 75 cm. What is the atmospheric in Pascal? Change from 75 cm mercury to Pascal. So what formula? Zhong Jiayin, you think you are here already. I ask you what formula to use?
Rho Hg.
Rho Hg, yes, correct. Rho Hg, so you get this answer. Okay? Remember, every time when you want to find the answer pressure in Pascal, so use Rho Hg. Density 1.4 10 power 4. H the height change to meter, 75 change to meter 0.75. And G gravity is 10 so you get 10500. Okay, A. Okay, number 14. Okay, copy down the answer, everyone. Okay. This question. What is the pressure at point X? Here, what is the pressure at here? Atmospheric pressure is 75. So what is the pressure at point X? So what answer? Tan Haoxiang, what is the pressure at this point? Donkey, yeah, 85. 75 plus 10, because over here is atmospheric 75 already. So another 10 cm. So 75 plus 10, so 85. Okay, number 16. Okay, what is the pressure at point X here? No, sorry, the gas X here, gas here. Normally, barometer here supposed to be vacuum, but here put gas already. Okay, you see the problem is like this, If no gas are here vacuum, this thing will go up to 75 cm, atmospheric pressure 75. If here is vacuum, definitely this one go up 75 cm. It's because of gas pressure. gas here lah. So this gas apply the pressure to push the mercury to go down to 20 cm. So what is the pressure of the gas here? How big is the pressure here? Yong Ching K. Yong, what is the pressure here? So what answer? Answer say, Yong Ching K, you say A. How can be A or gas, not vacuum, P 55. Yes, correct. Yong, correct. The answer is 55. So you minus. Without the gas, it will go up to 75. With the gas, it stop at 20. So what is the pressure here? So you take 75 minus the 20 lah. So meaning that here got pressure 55. Okay, 55 cm of mercury. Okay, next question. Which of the following not involving atmospheric pressure? Which apparatus are not using atmospheric pressure? Which one not using atmospheric pressure? Okay, Xiao Wei Zhen. Xiao Wei Zhen. Are you here, Xiao Wei Zhen?
Yes.
Xiao Wei Zhen, can you tell me or not? Which one not involving atmospheric pressure?
D, donkey.
Donkey, you sure or not? Bunsen burner need atmospheric pressure or not? Need or don't need? Okay, come I explain straight away. Okay. I believe not only Xiao Wei Zhen will say D. I think most students will say D. Actually, no. There's no answer here. Because string, rubber sucker, straw, all using atmosphere. Also Bunsen burner. You see this diagram. A Bunsen burner also need atmospheric pressure for what purpose? Nicole, can you explain? Nicole Chua, please.
Yes.
Nicola, can you tell me on this diagram how the atmospheric pressure help the Bunsen burner?
The oxygen go into the Bunsen burner, and then the Bunsen burner burns.
Yes. You need atmospheric pressure to help to push the oxygen gas go inside. Mix with the gas, then only the gas will burn perfectly. That's why I think Bunsen burner, you also know one, isn't it? There's a hole here, A hole can open, can close one, isn't it? The purpose of you open up the A holes is to let the atmospheric pressure push the air, especially the oxygen, go inside, mix with the gas, so that the burn is perfect. So indirectly, or not to say indirectly, it's directly, Bunsen burner also need atmospheric pressure so that the oxygen gas mix with the gas to burn. Okay, How Hanji, you agree my explanation or not? I know you got something else you want to argue. Do you agree or not? How Hanji? He say yes. He say yes, and okay, I'm happy already. How? Okay, number 18. The pump stick to the wall because of what reason? This is the rubber sucker lah. Why the pump? Ya, kenapa?
5 orang. Patut 29 orang buat macam you punya tak boleh dulu. Dia udah.
Dia orang hantar balik orang.
Susah dia orang kita nak 5 kita tahu
Itulah saya pun faham. Dia nak tak round kedua nanti akan ada.
Kalau buka sekolah boleh. Masalah kalau tak buka sekolah mau cari saya. Buat senang.
You ada jumpa pensawi ada cakap dengan dia lah. Okay. The pump stick to the wall because of what is okay? Last question now. Okay, I'll let you go already lah. Okay, just can someone please answer? Tan Shirley, can you answer? One answer. The pump stick to the wall because of what? Tan Shirley. Tan Shirley not there. Okay lah, Zhong Jiayin, please answer. Zhong Jiayin, why the pump stick to the wall?
C.
Yeah, C. Okay lah, because atmospheric. Yeah, thank you. Correct now. Atmospheric pressure more than the pressure inside the pump. So the atmospheric pressure will push the thing go to the wall lah. Okay ah. Okay, so I stop here lah, class. Okay. So hopefully you all follow what I say. Come and collect back your folder and pass up your lesson 2. You stapler your paper, no need folder, just pass up your chapter 2, lesson 1, the gas pressure paper, pass up. And at the same time, collect the module. Go home and do at home lah. Okay, Okay, find size 1 and size 3. Understand? Anyone here haven't sent your attendance? Send already? Everyone send already or not? Especially for those who came in late one. Send your attendance, please. Because the attendance I print out every day one, to keep a record one, who present, who never present. The one never present one, the marks is very low lah. Okay. Okay, all passed off, submit your attendance already. Okay. So take good care of yourself. So I see everyone again next week now. Okay, bye-bye. Find size 1 and size 3. Bye-bye, everyone.
Thank you, sir.
Yeah, okay.
sir.
Bye-bye. Bye-bye.
Thank you, sir.
Okay, bye-bye.
Thank you, sir.
Okay, bye-bye.
Thank you, sir.
Bye. Okay.